Hey guys, welcome back to another installment. Now in this video we'll be taking a look at control structures. Now there are a couple of them, so this video will be especially dedicated to that. We are still building our hangman project, so at the end of this video we will update our hangman file with the relevant concepts. So control structures are pretty much similar to variables in that they store data. However, control structures are capable of storing multiple values. Generally, control structures are used for data management and organization. Now, like I mentioned before, there are a couple of control structures. So we're going to be taking a look at those and which one to use for your problem. Now, the first control structure we're going to look at is lists. And in Python, lists are represented by square brackets. Just as the name suggests, we can store multiple values within a list. A list can be made up of any amount of values of any data type separated by a comma. So for instance, we could have an integer in a list as well as a string. We could also have a float in a list, and we could also have a variable, for instance. So we could declare a variable up here and then assign it the value for in Roman numerals, and then refer to the number inside the list. We could also have the boolean type in a list, and we could also have the none value in a list. Now we still have to store a list in a variable, so in order to use a list we can simply declare the variable name. We can call this one test and then print it out just to see the values inside. And there we have it. We have our values 1, 2, 3, a 4, a true, and a none. Now in Python, we can index a list to find a specific value. And the way that we do that is by placing square brackets next to the variable name that we are looking into, and then entering a number to find the value at that index. Now remember that in Python we start counting from 0, meaning that the first number in this list would be at the position 0 and 1 would be the second position in the list. Let's just look at that quickly. And there we have it. So if we look at the index 0, we find the value 1. If we look at the index 4, we find the value true, because even though the fourth value in the list is 4, the fourth index in the list is true. Now what we could also do is what is called slicing, where if we're looking for a range of values, we could simply write 0 and then a colon and then the 4. Now what this would do is return all of the numbers from 1 up until the num variable here, and then it would exclude the last 2. Now much like the range, what is happening here is the upper bound will be ignored, meaning we're going to get back 0, 1, 2, and 3. However, 4 and up would be ignored. Now if we save that and run it, we get back what we expect to see, the 1, 2, 3, and the Roman numeral 4. Now in Python, the 0 in a list slice is implied, meaning that we could leave this 0 out and we would still get back the same result, as you can see down here. We could also start indexing from the fourth index and leave this second number out if we want to refer to the end of the list. And there we get the last 2 values in the list, starting from the fourth index to the end. So now that we know how to slice, what we could do is save this new list into a variable. So we could create a variable named new list, and then slice the first 4 values, and then we could print that list out. Now we have a new variable called new list, and it has the first 4 numbers from the test list. Now say we wanted to add a couple of values to the new list. What we could then do is use a method called append, and how we do that is simply by calling our list that we wish to add a value to, and we add that dot and type in append. We open brackets and then we enter the value that we wish to append. So we like to enter the number 5 into our new list. We can save that, but first we need to print the new list. And if we run it, now we have a new list with the number 5 inside. Now the append function only takes one value. So if we wanted to add a couple of elements to the new list, what we could do is we could say new list equals new list plus, and then we could create a new list with the values that we'd like to enter. So we could enter 6, 7, 8, and then we can print the new list once again. And there we have it. In the first iteration, we created the list with just the values from the test list. In the second one, we added the number 5 using the append method. And then in the last one, we added 6, 7, and 8 using this method. Now, this line of code can be shortened just a little, where instead of typing new list plus our new list, we could simply type in new list plus equals and the new list. If we save that, we could run it and we get the same result. Now, a similar data structure that exists in Python is the tuple. And in Python, the tuple is represented by a set of brackets or parentheses. The key difference between a list and a tuple is that a tuple is immutable, meaning that it cannot be changed once it is created. So for instance, we could have a list like before, and we could call it new list, and we could have the elements 1, 2, and 3, and then we could have a tuple and then give it the values 6. Now with lists, it is possible to change the values by simply going to the index and we could, for instance, change the number 2, which is at the position 1, and say that it is now equal to the integer 2. And if we print our list out, now we just reassign the string 2 to the integer 2, and that's what we get when we print it out. Now with tuples, however, we cannot do that. So for instance, if I try to do the same thing, instead of list, we type tuple, and we change the second value in the tuple to a 5, an integer 5. If we try to do that, we get a type error because the tuple does not support reassignment, because like I mentioned, the tuple cannot be changed once it is created. So it is very much possible to append to a tuple, for instance. So for example, we could do something like new list plus equals 6, and we could do the same for tuples. We could do we get a new tuple. Now the reason why this works for tuples is because this is essentially reassigning the value. of tuple. So it is not changing tuple, but completely reassigning it. Like we saw earlier, what is actually happening here is new tuple is being reassigned to being new tuple plus this new list. So essentially, with reassigning, you could look at it like this, where we're taking the new tuple and we are reassigning it to the value in new tuple combined with this tuple, which is why reassigning is possible. However, redefining values within a tuple is not possible. Otherwise, anything outside of that is pretty much still the same. So we can still index a tuple. So we can print out a specific index that we want. We could print out a new tuple, and we could index the second value. And we print that out. We get v. We could also slice a tuple. So we could say show me from the beginning to the end, and we still get the entire thing. We could also say show me the second value until the end, and we get exactly what we expect. Now, one last thing I'd like to demonstrate with tuples is something called tuple unpacking. So for instance, let's add these numbers to our tuple and get rid of that list. Now what we could do is we could declare new variables and say 1, 2, 3, and then we could say, okay, have a last one called numbers, and then add a star to it, or let's say remainders, and then we could say new tuple, and then we can print out these new values. We could print out 1, 2, 3, and then print out remainders. Now what essentially happened here is we assigned the values that were in new tuple accordingly to the variables that we had before our equal sign or our assignment operator, and then we only explicitly assigned the first 3 values, and the remaining values were all saved as a list in our last variable that we called remainders. Now notice that we added this star here at the end. It is important to not forget this, because if we forget that, then we will get an error. Forgot what the message is, but we get an error that tells us that there are too many variables here. Value error. There are too many values to unpack. What this is essentially saying is that there are more than 4 values to unpack from the new tuple variable than we have created variables for. So if we just want to put everything else that remains in the tuple, we have to add that star before the variable name, and then we can run that and it'll create a new list and save everything that wasn't assigned to its own variable in the last variable. In an earlier video, I made an example with strings and how we could do something like this, and we could print it out and we get exactly what we expect. However, I mentioned that if we saved this to a variable and we try to print that out, we wouldn't get what we expected. Now, the reason why this happened is because this is also a way of declaring a tuple. So if you want to declare a tuple, you can either use brackets around whatever it is that you're creating, or you could simply separate your values with commas, and you'll get back your new tuple. Another data structure we have in Python is the dictionary data structure, which is represented by curly brackets. Now, much like a normal dictionary would have a word and its definition, a dictionary in Python takes in a key and a value. Furthermore, just like an actual dictionary, a Python dictionary also does not support duplicate keys. For instance, let's say we manage the Instagram login accounts. We could create our own database and assign it to a dictionary. How that would look with the dictionary is we could do something like user1, and then their password would be the value. So we could say passcode 1, and then we separate it by comma, and we have a new user, and we could call that user 2, and then give them their password, and then have a third user, and that would be our database. Now, the way that we index a dictionary is simply by using the variable name and then using square brackets, and you can see our IDE suggests the keys that are in our dictionary. So we could simply use one of the keys, and we could print out whatever is returned by this specific key in our dictionary. So if we wanted to find out the passcode for user 3, there it is. We do that by using by indexing the username. A way we could use this in a project is we could do something like user and get user input from our user. We could do something like enter username, and then we could have a variable for the password, and then say password. And then what we could do is say if database user, and what this is going to do is it's going to take the username that we received and then go into the database and look up the username's passcode. So we could say if database user, if the passcode returned by this is equivalent to the passcode that the user entered, then print welcome back user, else print invalid username or password. So if we ran this program now, okay, let me just clean this up real quick. Let's try it again. If we run the program now, it says enter user. We're gonna enter user1, for instance, and then it's asking for the password, which is passcode 1, and we enter that. Okay, what is it? Oh, passcode with 1s. Okay, so let's run that again. Say user1, passcode 1, and it says welcome back user1. And if we entered it correctly, which we already saw, let's say user2, and let's say passcode instead. there we get invalid username or password. Now what if we entered a username that wasn't in the system? What will happen then? Let's say we entered user4 instead, and let's say password was their password. Now we would get a key error. Now what this is essentially saying is that the key user4 does not exist in the database dictionary. Now a way we could get around that is by using a function called get. So how the get method works is we can do something like this. We could say print database and then get, and now get takes two parameters. The first parameter is the key that we're looking for, so we could say user4, and then the second parameter is the error message to show if the key that we are looking for was not found. So in this place we could say user not found. Okay, so let's just comment these out for now, and we save that and we run it, and it says user not found because we don't have a user4 in our database. Now we could also leave this blank, and if we leave that blank, we get back a none result. Maybe get none. So now we can use this. We could say if database get, and then into the user variable, which will have our username. So if the username is none, so if we run the get method and we return none, meaning that the username was not found, then we could print out user not found. Then we could have an else if statement, and we could say otherwise if database is equivalent to so meaning that now the username is going to be found, and now we're just checking if the password returned is if the password returned is equivalent. Now we can print welcome back user. Otherwise we can now change this because we know that in this case it would be the password that is wrong. So essentially what this is saying is, okay, the first statement is checking if the user exists in the system. If it's not found, then print user not found. If the user is found in the system, it'll check if the password is equivalent to the passcode that the user entered. If that is true, then it'll print welcome back. If these two aren't true, that means that at the least the username was correct, however the password was incorrect, so it will print out invalid password. And now we can print this out. We can run the program and check it out. So it says enter username, we'll enter user1. It says password, let's put an incorrect password, and it says invalid password. Okay, we run it again. This time we run it with a user that doesn't exist, so user4, and the password doesn't really matter, so it says user not found because the user was not in the database. Now lastly, we can run the program and enter the correct details. So check for user1, and then we check for passcode 1, and it says welcome back user1. Now finally, if we wanted to look into our database and find all of the users or all of the passwords, what we could do is something like this. We could use a method for finding all of the keys. We could use a method called keys, and we just simply write out database and then keys with no arguments. And what this would do is it would return a list with all of the keys in the specified dictionary. So there we have user 1, 2, and 3 all found in the dictionary. And if we wanted all of the values, we'd use a method with the same name, let's say values, and then we'd run that, and we get back all the values in the dictionary. If we wanted to find both the keys and the values within the dictionary, we could use a method called items, and that would return a list of tuples. So each item in the list is a tuple of the key and the value, and second key and value, the third key and value. Now often what we then do with something like this is we could run a program like for kv, which actually stands for key value. So for key and value in database items, print, and we could do something like key and what this is going to do is it's going to print out all of the keys and values side by side. So let's run the program, and now we have user1 passcode, user2 password, user3 passcode with an O. And that is how we work with dictionaries. Now the final data structure I want to show you guys is the set data structure. It is similar to the list and tuple data structure in that it stores multiple values. However, it is also similar to the dictionary in that firstly it is identified with curly brackets, but most importantly it does not support duplicate values. We could create a list, let's call it new list again, and then we could have, and let's say a 5. Now if we were to create a set with the same values, and we printed that out, you will notice two things. The first thing you'll notice is that 1 was deduplicated, meaning that we only returned one instance of 1, like all the duplicates were removed. And secondly, you'll notice that the order is no longer the same. So something else about the set data structure is that it does not preserve the order of values inside the set. This also means that we cannot index a set. However, there are ways to find out if a value is in a set or if it isn't. So for instance, we could do something like this. So we could say true in set, and that should return true. There we have true. Additionally, we could also add values to a set. Now the way we do that with a set is we use the add method. So we could say add 25 into our list, and when we run our program, we get back a new set with 25. We could also remove values in a set by simply using the remove method. So we could say new set remove 3, 0. And we save and we run our program, and now we have a new set minus the value 3, 0. Now the set data structure also features a couple of its own interesting operators. Now for instance, we could create two sets. Let's change this to first set, and then change this to second set, and in the first set we'll change the numbers up a bit. And here we can also add a couple more. Let's just add 10. Okay, now we could do what is called a union, where we can combine two sets to form a new set. Now the way we do that is by using the pipe symbol, which is found above the enter key. We add the first set and the second set, and if we print those out, then we also print out the sets themselves. And so we have the first set and the second set, and then we have a new set with all of the values from both sets, excluding duplications. So you'll notice that 5 only appears once and 10 only appears once in the new set. Another operator that we can use with sets is the intersection operator, which is represented by the ampersand or the and sign. What this one does is it gets items only in both of the sets. So if we have a value that is in the first set and the second set, we will return a new set with all of those common values. And we see here we have 10 and 5, which are the only common values in the two sets. Another operator that we have is the difference operator, which gets items that are only in the first set but not in the second set. The difference operator is represented by the subtraction sign. What this is going to do is it's going to get all of the items that are in the first set that aren't in the second set. And if we save and run that, we get back all of the values in the first set that are absent in the second set. And we can swap these around as well. And now we have all the values in the second set that are absent in the first set. The final operator that we have is the symmetric operator, or the symmetric difference operator. What this one does is it will return all the values that are not in both sets. And if we run that, now we have all of the values minus the values that are in both sets. So for instance, we don't have 5 and 10 which occur in both sets. However, we have the rest of the values from both sets.